Today, we're here to talk about the macromolecules and the fed versus fasted cycles. Our macromolecules are kind of our main molecules that makes us who we are and will drive all the processes in our body. The three main ones that we're going to focus on today are carbohydrates, proteins, and fats, because these are the ones that you eat, but nucleic acids are also considered a macromolecule. First off, carbohydrates are the body's primary source for energy. Cells will want to burn this for fuel, and this will help us create energy to be human and do whatever we want on a daily basis. Carbohydrates are also used for different components of cells and aid in a little bit of structure, but mainly they're for fuel. Proteins, on the other hand, their primary job is to function with structure, movement, our muscles. They'll help, that muscle contraction. And they also are used in enzymes, which are proteins that aid in reactions throughout the body and just regulating how our body drives and how it moves. Fats, those are our storage of energy, and those are kind of when we have an excess amount of energy, we'll store it as fat. But as we'll see later, that we'll actually want to use fats as an energy source for our cells as well. And we'll talk about this later, like I said, as to why this is important. And then finally, nucleic acids. This is our genetic material. It makes us who we are. This is your DNA and our genes. So what is a polymer and what is a monomer? So a polymer is many monomers linked together to form a macromolecule. So for example, carbohydrates, monosaccharides, or one sugar molecule are linked into these long chains to produce carbohydrates. Again, similarly with proteins, these amino acids are the monomers and they're linked together in chains and they're folded to form proteins. And we'll touch on this a little bit later, but amino acids, there's essential versus non essential amino acids, and they have a little bit of a different role in the body. Then finally, fats or triglyceride are three fatty acids connected to a glycerol or sugar backbone.
And as you can see in the diagram here, you can see example for glucose, the sugar molecules linking together to form carbohydrates, the amino acids coming together to form proteins, and the glycerol and fatty acids forming lipids. So the Randall cycle order of burn, this is the order of how we want to burn for energy. So number one, we want to burn carbohydrates first. This is something that the body uses first in energy. And the second thing that we want to use is fat. You do not actually want to burn protein. That's why it's in red there at number 3, as its main purpose isn't really to be used for fuel. So here with this figure 8 loop, you can see what you want if you're metabolically flexible is to be able to switch between burning carbs to fatty acids. Your body is going to burn carbs first, and once it runs out of carbs to burn, it'll go straight to fatty acids to burn. So
Exactly. And this will be important in our fed versus fasted cycles as well. So we'll see this relationship between the order of burn kind of touch back there. So carbohydrates.
yeah, so there's many different types of carbohydrates, starting with the starches, amylose. This is a slow burning starch. It's something you see in healthier foods, for example, nuts, beans, and oats. And amylopectin, this is a starch as well, but it burns a little bit faster than amylose. Um, this can lead to higher blood sugar, and you see this more in processed carbs. And then lastly, you have cellulose here. This is what you see more in raw vegetables. This actually cannot be broken down and it's not digested, so it goes straight to the colon. But it's really healthy as it's good fuel for your microbiome. And then you have sucrose, lactose, and maltose. These are simple sugars and they're digested very fast. And these are not good carbs as they have fructose, which is not healthy for you. And here you have some of the problems of excess glucose consumption. Um, excess glucose, it can be converted into triglycerides, which are fats by the liver. And also you have insulin, it can lead to an insulin spike, leading to insulin resistance, which can cause the trigger of cortisol release.
Yeah, and it's important to note too that cortisol is a hormone that's a stress hormone, kind of indicated down in this lower picture. And when this is constantly on, it actually changes our genes a little bit and shifts us in directions that we don't want to go. So this constant release of cortisol caused from excess glucose consumption and high insulin will be a problem. And we'll touch on it a little bit later, but we don't want a lot of cortisol. We don't want a lot of insulin in the blood. And the fourth reason why excess glucose consumption can be problematic is glucose is actually fuel for cancer cells. So, if you're in this excessive state of growth constantly, glucose is going to be feeding into those tissues and just make the problem worse. Chronic high levels can result in the activation of the polyol pathway, and this pathway is actually detrimental to our nerve cells and kidney cells and eye cells because when we activate this pathway, it causes our cells to actually break open and we get this neurodegeneration, we get clouding in our eyes. And just because of these concentration gradients of glucose, it can be detrimental to our cells and actually destroy them when we don't want to be destroying them. And then, like Tommy said, with some of those simple sugars like sucrose and high fructose corn syrup, fructose is actually a sugar that will be converted straight to fat by the liver. And this is different than glucose because glucose can actually be used as fuel, but fructose is bad because, like I said, it goes straight to the liver and can cause non-alcoholic fatty liver disease and cause much more problems with that excess fat. So now we'll touch on a little bit more on fats and the different kinds of fats. So first we have our unsaturated fatty acids, and you might have heard of these before, your omega-3 versus omega-6 fatty acids, and this kind of aids in our inflammatory response. So it's important that we're getting the right ratio between the two. We also have saturated fats, which are in like butters or animal products. And traditionally, we're led to believe that these fats are bad, but if we consume them right, they're actually not as bad as we think. So important to keep in mind. And then we have trans fat. Trans fat is a man-made fat that is really bad for our body because we can't break it down as easily because it's been manipulated and it's been changed, and it's in a lot of our foods that we don't even think that they should be in. So important to look out for those as well. So, like we kind of talked about earlier, fats actually yield more energy when burned than carbs do. So, it's important to think that we want to get to a fat burning stage. But it's important to note that they're actually burned after carbohydrates. So, we must burn all our carbs or not eat as many carbs in order to burn fat. Um, like I said, if carbohydrates are present, fats will actually be stored in our adipose tissue. So, if you're eating a high combination of the two, the fat's going to go straight to the adipose, where the glucose is going to get burned first, kind of relating back to that order of burn. Um, and then our adipose tissue is made up of triglycerides. This is kind of your fat around your arms, your fat around your face a little bit, that kind of squishy fat. It's your storage form of fat. But interestingly enough, when we get into this fasted state, or if we're metabolically flexible, where we can switch between our fuel substrates, we're actually able to pull fats from our adipose and use them as fuel. And we actually get a lot more energy when we do so. So it'll be important to note when you guys are going through your diets to, realize that fat is actually good and we want to burn it. Then a little bit more about omega-3 versus omega-6. Real quick, omega-3 is aiding in your anti-inflammatory response. So we want more omega-3 fatty acids in our diet versus omega-6 with all this nut oil, your vegetable oils, kind of your processed oils. You're going to get more inflammatory response because of it. But the omega-3, the way it's made up, you're going to actually turn off this response and you'll be feeling better, your immune response will be better, you'll be sharper in the mind. And we'll see this kind of in our walnuts, traditionally our fish, our cold water salmons, as it says, pecans, leafy greens. So just important to make sure that ratio is down. And important important thing to note is Americans actually are around, a 40-to-1 omega-6 to omega-3, and this number changes, but we have ate so many more omega-6s than we should be, and we should be around a 1-to-1 ratio. Then with proteins, we have 20 actually different amino acids, and these are our building blocks, our monomers, and 10 essential amino acids, kind of like I talked about earlier, essential versus non-essential. Essential, we must eat these because our body can't produce them or recycle them. So we have to eat these, and these kind of come from our animal products, our meats, our eggs, our milk, and our 10 non-essential amino acids, we can actually recycle amino acids and create these internally. So these aren't as important to be getting in your diet, but still you want a nice balance and you want to be eating